I want you to do something, well, a little radical right now. Wherever you are, whether you're commuting, making coffee, or just staring at a wall, I want you to completely wipe the word anthropomorphic from your brain.
Yeah, just delete it entirely.
Right. Just get rid of it. And while you're at it, take all those sci-fi movies you've ever watched. You know, the ones with the glowing red camera eyes or the robots suddenly developing a soul in the third act.
Oh, yeah, the classic Hollywood tropes.
Exactly. Toss those out too. Forget the whole concept of digital life. Just let it go. Because today, we are going to look at what is actually happening when you type a question into an empty text box. No magic, no ghosts in the machine.
Honestly, it is incredibly freeing to just let go of those sci-fi narratives. I mean, we cling to them because they're familiar, right?
Yeah.
Humanity has always loved stories about creation, like building something in our own image.
From Pygmalion to Frankenstein.
Exactly. But when we apply the ancient storytelling instinct to what's actually happening in modern computing, it completely blinds us. It makes us afraid of the wrong things, and it makes us misunderstand the tool we're actually holding.
And that is exactly the mission of today's deep dive. We are breaking down a really fascinating, deeply pragmatic, and honestly, somewhat rebellious document titled AI Extension Outline.
It's a great read, very direct.
Yeah, the author of this document has a single, relentless goal, which is to strip away the sci-fi exterior of artificial intelligence and show you exactly what is under the hood, the plumbing, the math.
Which is so necessary right now.
It is. We want to give you, the listener, the ultimate shortcut to understanding this technology, not as a magical entity, not as a digital friend who cares about your day, but as a highly advanced, mathematically inevitable tool.
Because understanding the mechanics, the actual gears turning beneath the screen, is really the only way to avoid being completely overwhelmed by information overload in the modern era. I mean, if you don't understand the tool will manipulate you.
Or the people selling the tool will manipulate you.
Yeah, exactly. Even more likely.
So, before we can build up your understanding, we have to tear down the false narratives. The author of our source material makes this incredibly clear right out of the gate. AI is not mysterious. It is not pondering things. It operates on complex electronic pulses running basic math.
Yep. Addition, mostly.
Right. At its core, at the bedrock level of the silicon, we are talking about addition inside integrated circuits. That's it. Millions of microscopic switches flipping on and off.
And this is a point that people really struggle to internalize. There is no real randomness or probability or prediction happening at the computer's base level, not in the way a human experiences those things anyway.
So when companies use those words,
Yeah, when an AI company says their model is predicting the next word, they are using a human figure of speech. They're borrowing our vocabulary to explain a math equation. In reality, every single output, like every word in an essay, every pixel in an image, every line of code it generates, is a mathematically inevitable result of specific data running through specific code. If you have the exact same starting state and the exact same inputs, you will get the exact same output. It's totally deterministic.
it's a machine running a calculation, period. So if it's not a digital brain, what is it? I really love how the document defines this because it gives us a core definition to anchor everything else.
The compression package concept.
Yes. It says AI is simply a compression package of all human wisdom. It takes the language, the data, the logic, and the millions of experiences that humans have produced throughout history, and it bundles them all together into a searchable format.
Think about the progression of how we find things out. For a long time, we used what we might call first-generation search engines. You'd go to Google or Baidu, type in a query, and the engine would hand you a list of links.
Right. It was saying, here are places where someone might have the answer.
Exactly. And then you had to do the manual labor. You had to click the links, read the web pages, filter out the garbage, and synthesize the actual answer in your own head.
You were the processor. You had to connect all those dots.
Right. What this new generation of technology does is use its underlying architecture to repackage the answers that humans have already figured out. It bypasses the links entirely and gives you the synthesis.
So the prompt is just the search term.
Exactly. In this new paradigm, your prompts are just the new search terms. You aren't asking a digital god for a revelation. You are querying a hyper-compressed package of human history.
That makes perfect sense logically. I mean, thinking an AI has a soul because it gives you a brilliant answer is like thinking a public library is a living, breathing genius just because it has millions of books inside it.
Yeah, it's a repository.
But hold on, I have to challenge this a bit because logic only goes so far when you're actually using the tool. If it's just a giant fancy search engine, why does it feel so intensely personal?
Oh, I know where you're going with this.
Right. Like if I tell a chatbot, hey, I'm having a terrible day, I just lost my job, the response I get feels incredibly empathetic. It validates my feelings.
Right.
A Google search doesn't give me empathy. How is a math equation doing that?
Well, this is where the author brings in the concept of nothing new under the sun. And it's the key to the whole empathy illusion. We really struggle to comprehend the sheer scale of the human population and the digital footprint of human history.
It's too big to wrap our heads around.
Exactly. Because there are billions of us, and because we've been posting our thoughts online for decades, almost any problem you are facing, any emotion you are feeling, any hyper-specific anxiety you have, it has already been faced, felt, and written about by someone else.
So when I type, I lost my job, I'm not the first person to type that into a computer.
Far from it. Millions of people have sought comfort for that exact situation online. And thousands of humans have responded to those people with highly effective, comforting, empathetic advice. So the AI feels empathetic to you because it is perfectly matching your search term, your prompt about losing your job, to thousands of validated, pre-existing human experiences that it has mapped in its database.
So it's mathematical alignment.
Yeah, it is mathematically aligning the parameters of your query with the parameters of historical human responses that have been statistically graded as empathetic. It's basically a mirror.
That is just wow. So think about that the next time you feel an AI really gets you. It wasn't sitting there feeling bad for you. It wasn't creating a new emotional thought. It was perfectly reflecting humanity's collective past right back at you.
It's not a ghost in the machine. It's an echo of billions of human voices.
That is profound. It really reframes the whole interaction. You're talking to the sum of humanity.
Right.
But to truly demystify this, we have to look at the physical reality of how this echo chamber is constructed.
Right, the actual architecture.
Because if we accept that AI is essentially a massive, highly efficient search engine of human history, we need to know exactly how the engine is built. The source breaks this down into three foundational pillars: data, compute, and algorithms.
Or, if you want to think about it mechanically, the fuel, the heart, and the blueprint.
I like that. Let's start with the fuel, the data. We've been living in the internet era for a while now, and the result is an absolute explosion of raw information. The source notes that by 2025, global data storage is projected to reach 175 zettabytes.
Which is a staggering number.
I actually tried to look up what a zettabyte is before we started, and the numbers are just dizzying. If each gigabyte in a zettabyte were a brick, you could build the Great Wall of China millions of times over. It is an unfathomable, oceanic amount of information.
It is. But here's the catch. Having an ocean of data doesn't mean you have an ocean of fuel. The vast majority of that 175 zettabytes is absolute garbage.
Like spam and bad photos.
Yeah, it's blurry photos, corrupted files, repetitive spam, and incoherent text. If you just take a giant pipe and feed the raw, unfiltered internet into a computer, you will get a disaster. The machine will learn nothing but noise.
Garbage in, garbage out, the oldest rule in computer science.
Precisely. So the source points out that to turn this raw data into viable AI fuel, it requires extreme cleaning, filtering, and a process the author refers to as dehydration.
Dehydration, like removing the water.
Metaphorically, yeah. The tech companies have to scrub out the noise, remove the duplicates, strip away the irrelevant formatting, and boil it down to pure information. But here is where the document reveals something truly fascinating.
What's that?
Out of all that data, out of all the encyclopedias and novels and articles, the absolute highest quality fuel for training an AI is actually code.
Like computer programming code.
Yeah.
Python, C++, Lite, stuff from repositories like GitHub.
Yep, exactly.
Why would that be the best fuel? I would think philosophy books or history textbooks would make it smarter.
You have to think about how a machine learns logic. Human language, even in a well-written textbook, is messy. It's full of slang, idioms, double meanings, metaphors, and illogical leaps.
That's true.
Like, we say things like it's raining cats and dogs, and we expect the listener to just know we mean heavy rain. But code is strictly, uncompromisingly logical. If the logic in a piece of code is flawed, the program simply will not run. It crashes.
Right, it has to be perfect.
Therefore, a massive repository of functional working code on GitHub is essentially a massive repository of perfectly structured, verified cause and effect logic chains.
Oh, that is brilliant. That explains a massive mystery for me. When ChatGPT first blew up, everyone was shocked at how incredibly good it was at writing code.
Yeah, people thought it was magic.
But it wasn't just that it learned the syntax of Python. By reading millions of lines of functional code, it absorbed the very concept of perfectly structured logic. It learned how to construct a flawless argument, because that's what a working piece of code actually is.
Exactly. It uses those rigid, perfect logical structures it absorbed from GitHub to better organize and process the messy, chaotic human language data it also ingests. The code acts as a scaffolding for the language.
Okay, so we have the perfect fuel. We have the zettabytes of clean, dehydrated data structured around pure mathematical code logic. But having the world's best fuel doesn't matter if you try to put it into a horse-drawn carriage.
His hardware was completely wrong for a long time.
Right. And this brings us to the compute, the heart of the AI. The source takes us on a bit of a historical detour here, contrasting our traditional computers with what we need today.
This historical context is vital because it explains why this revolution is happening now and not, say, 20 years ago. For decades, traditional data centers and personal computers ran on CPU central processing units.
Which we're all familiar with.
Right. Think of a CPU like a single, incredibly fast sports car. It can take a complex sequential task, drive it from point A to point B at breakneck speed, and then move to the next task. That's great for opening a spreadsheet or running an operating system.
But not for AI.
No. AI training doesn't need to do one complex thing really fast. It needs to do millions of tiny, simple math problems simultaneously.
So a sports car is useless if you need to move 1 million people across town at the exact same time. You don't need a Ferrari. You need a massive fleet of public buses.
That's a great way to look at it. And that massive fleet of buses is the the graphics processing unit.
Which is so funny because GPUs were built for teenagers playing video games.
They were. Back in the 90s and 2000s, video games started using 3D graphics. To render a 3D environment on a screen, the computer has to calculate the shifting colors and shadows of millions of tiny individual polygons, all at exactly the same fraction of a second, 60 times a second.
And a CPU just couldn't handle that.
Not a chance. So companies like NVIDIA built GPUs, which were designed specifically for parallel processing, doing millions of dumb calculations at the exact same time. Later, that same architecture turned out to be perfect for crypto mining, which was also just doing massive amounts of parallel math.
And then the AI researchers realized, wait a minute, training a neural network is mathematically identical to rendering a shadow in a video game. It's all just parallel matrix math.
Exactly. And the source highlights a very specific, almost cinematic historical moment here. It points to the year 2015 when Elon Musk co-founded OpenAI. AI was still seen as a bit of a backwater by the general public back then.
Sure.
But there's this incredible detail. Jensen Huang, the CEO of NVIDIA, personally delivered the very first AI supercomputer, a box called the DGX-1, directly to Musk at OpenAI. And significantly, the supercomputer was equipped with graphics cards named the Tesla P100.
That feels like a massive inflection point. The hardware finally met the software.
It was. NVIDIA realized earlier than anyone else that GPUs were the future of all computing, not just gaming. And they didn't just sit on their laurels. They started building an incredibly deep moat around their technology. They realized that making the chips faster wasn't the only problem. The problem was the bottlenecks.
What do you mean by bottlenecks? If the chips are fast, why is there a bottleneck?
Imagine you have 1 million of those buses we talked about, and they are all full of data, ready to go. But to get from the processor to the computer's memory, all 1 million buses have to squeeze through a single-lane toll booth.
Oh, I see.
It doesn't matter how fast the buses are, traffic is going to back up. That was the reality of traditional computer architecture. So NVIDIA invented something called NVLink. It essentially busted down those data walls, building massive multi-lane superhighways between the chips, allowing them to talk to each other at unprecedented speeds.
The source also mentions HBM, high bandwidth memory, which essentially does the same thing for the memory chips themselves, stacking them vertically like skyscrapers to shorten the distance data has to travel. It's all about moving gargantuan amounts of data instantly.
Exact.
Now, I want to stop here for a second because we need to address something. If you turn on any financial news network today, you will hear pundits screaming that AI hardware, and NVIDIA specifically, is just a massive stock market bubble. They compare it to the dot-com crash. They say it's all just hype.
Well, the author of our source document strongly vehemently disagrees with that assessment.
And honestly, based on the mechanics we were talking about, I have to agree with the author. This isn't a bubble. It is a fundamental restructuring of global productivity infrastructure. We are moving from the CPU era to the GPU era.
It's like the shift from steam power to electricity in factories. The machines fundamentally run differently now.
Exactly. And the author uses this amazing spatial analogy to explain NVIDIA's newer technology, the tensor cores, which I think really helps visualize why this hardware is so untouchable right now.
Yes, let's unpack that analogy. It's about fundamentally changing how a machine reads data.
Right. Let's imagine how a computer absorbs information. If you are a traditional CPU, you are reading in one dimension. Imagine looking through a tiny peephole and reading a single line of text, letter by letter, word by word, moving from left to right. It takes time.
Lots of time.
Now imagine you upgrade your hardware, and suddenly you can read the entire flat page all at once in 2 dimensions. That is exponentially faster.
But a tensor core takes it a step further.
Exactly. What the tensor cores do, essentially, is allow the machine to read the entire book instantly in 3 dimensions, or even higher dimensions, mathematically speaking, through something called matrix multiplication. You aren't just speeding up the line-by-line reading, you are changing the geometry of how information is absorbed.
It's hard to visualize, but yeah.
A tensor core grabs a massive cube of data and processes all the relationships inside that cube simultaneously.
And that is what allows an AI to look at, say, an 8K video file, which is a gargantuan amount of data, gigabytes of shifting pixels, and process it as easily as a text document. It isn't scanning the video frame by frame, line by line. It's analyzing it across multiple mathematical dimensions simultaneously.
Okay, so we have the clean data fuel, and we have this unbelievable multidimensional GPU heart. Now we need the architecture to actually put them together, the blueprint. And this brings us to the algorithm, specifically the transformer architecture.
This is where we really have to be careful with the words we use. Back in 2017, researchers at Google published a famous paper that introduced this architecture. The paper was titled, "Attention is All You Need."
Right. That paper is legendary in the tech world.
But the author of our source warns us that the term attention is a highly misleading anthropomorphic trap.
Because it makes us think the computer's paying attention to the text, like a student furrowing their digital brow and concentrating.
Exactly. The machine isn't focusing. It has no consciousness to direct. What the transformer is actually doing is calculating weight distribution and coordinate linking. It's mapping mathematical relationships.
How does that actually work? Break that down for me.
Let's take the word bank. If you just have the word bank in isolation, it means nothing. It could be a river bank or a money bank.
Sure.
But the transformer looks at the surrounding context. It calculates mathematically how strongly the word bank relates to the word river versus how strongly it relates to the word money or Wall Street in millions of different sentences. It assigns a numerical weight to these relationships. It essentially creates a massive, invisible, multi-dimensional web of gravity where words pull on each other based on how often humans have linked them in the past.
That makes sense. It's mapping the conceptual distance between ideas. So let's walk through what actually happens when you sit down on your laptop and type a prompt into ChatGPT or Claude.
Let's trace it.
The expert in the document breaks down the actual machine process, step by step. Let's say I type in the prompt, explain quantum physics like I'm a 5-year-old. I hit enter. What is the machine actually doing in those 3 seconds before it replies?
Let's trace the exact mechanical path. Step 1. You input your question. Now, the machine does not read your English words. It can't.
Right.
So step 2 is translation, or what engineers call tokenization. It takes your human words and turns them into a digital structure, a series of mathematical coordinates in that massive web we just talked about.
Okay, so it turns the English word quantum into a multidimensional number.
Right. Step 3 is splicing. It breaks that math down into the smallest logical units. Then comes step 4, autoregressive comparison. This is the heavy lifting.
What does that mean practically?
It takes your tokens and dives into that massive pre-calculated web of weights. It is blindly searching for the mathematically optimal paths that connect your tokens to the data it absorbed during training. It's looking for the strongest gravitational pull.
It's finding the trail of mathematical breadcrumbs left by everyone who has ever talked about quantum physics in 5-year-olds.
Exactly. But remember, you didn't just ask about physics, you asked it to explain it to a child. So step 5 is applying a template.
Ah, the style.
Yes. The system has structural parameters built in for what a teacher or a simple explanation looks like. It forces the mathematical search results through that specific stylistic template. Then, step 6, it translates those mathematical coordinates back into human words. And step 7, output. The words appear on your screen.
7 steps: question, translation, splicing, comparison, searching weights, applying template, output. And none of those steps involve thinking. None of them involve understanding.
Not even a little bit.
It is purely a multidimensional path search.
Yeah.
And it happens in milliseconds. The source points out that Google played a massive early role in proving out this kind of exhaustive data approach with their Project AlphaGo.
AlphaGo is the perfect historical proof of concept for this. When Google's AI defeated Lee Sedol, the human world champion in the complex board game of Go, people thought the machine had achieved human intuition.
I remember that. People were freaking out.
They thought it was outsmarting him, but it didn't do it by being smarter in a human sense. It did it by using exhaustive data and weight mapping. It had played millions of games against itself, mapping out the mathematical probability of success for every conceivable board state.
So it was just math again.
Yeah, it defeated human thinking not with better thinking, but with an overwhelming, perfectly mapped database of cause and effect.
Okay, so if we have all of this figured out, if we have the 175 zettabytes of clean fuel, the hyperdimensional GPU hearts, and the transformer blueprint mapping all the weights, why didn't AI take over the world years ago?
That's a great question.
Why did it seem to just sit in research labs and then suddenly burst onto the public scene out of nowhere with OpenAI's version 3.5?
Because a raw AI Model 1 that just has the data, the compute, and the transformer algorithm is, as the author brilliantly puts it, a lunatic.
Ugh.
A highly capable, incredibly fast lunatic full of knowledge. It desperately needed an intervention before anyone could use it.
This brings us to my favorite part of the document,
Right.
because it highlights a fundamental flaw in the whole system, and that flaw is humanity. Human wisdom is inherently flawed. It's contradictory, it's full of terrible biases, and it's often just plain wrong.
Right. If you take a raw model and feed it the raw internet and you let it just follow the mathematical weights without any guardrails, it will output toxic, racist, or completely nonsensical information because that darkness exists in the data.
Of course it does. We wrote it.
Furthermore, as we discussed earlier, human language is what the author calls a weak rule system. It's divergent, it contradicts itself constantly.
Unlike the code from GitHub, which only has one right way to run.
Exactly. Because human language is so loose and sloppy, a raw AI model can easily get lost in the mathematical weights. It will connect concepts that shouldn't be connected, and it will do so with absolute, chilling mathematical confidence. This is what causes AI hallucinations.
Right, where it confidently outputs total fiction, like making up legal precedents that don't exist, or inventing historical events and arguing with you that they are real.
Yes, because to the machine, the mathematical path it found is perfectly valid based on the sloppy human data it read. So how do you fix a hallucinating, toxic digital lunatic?
You bring in the correction fluid.
Yes. In the tech world, this correction fluid has a very sterile name. RLHF, reinforcement learning from human feedback. But again, the source begs us to strip away the anthropomorphic words. Learning and feedback make it sound like a teacher grading a student.
And the author is adamant, these are not actual rewards or punishments. The machine does not feel pride when it gets a reward, and it does not feel pain or shame when it gets punished. RLHF is simply forced manual human intervention into the data weights.
Let's talk about the physical reality of how this actually works, because it's not glamorous. It relies on armies of human annotators. Tech companies hire thousands of click workers, often in developing nations, who sit in office chairs and stare at screens all day looking at outputs from the raw AI.
So the model might generate answer A and answer B to the same prompt.
Right, and the human annotator evaluates them. They click a button that says, answer A is helpful and safe. Answer B is factually incorrect and slightly aggressive. Answer A ranks higher.
So they are manually grading the math. They are standing over the machine and pointing.
Yes, and by doing this hundreds of thousands or millions of times, they create a separate algorithmic layer called a reward model. Think of this reward model as a digital sensor that sits inside the system. Yeah, this reward model fine-tunes the AI. It goes back into that massive web of weights and forcibly alters the math. It creates a mathematical dead zone around the toxic stuff, effectively lowering the probability that the AI will ever travel down those garbage paths and heavily raising the probability that it will travel down the safe, helpful paths.
It's artificially changing the gravity of the words. But this raises a really fascinating, somewhat troubling consequence that the text points out.
The alignment tax.
Exactly.
Right.
This correction fluid makes the AI safe for public consumption, absolutely. It stops it from acting like a lunatic, but it also makes it incredibly boring. It makes it restrictive. It turns the AI into what the author calls a digital sycophant.
Right. When you force a model to be universally polite, perfectly safe, and utterly inoffensive, you blunt its edge. You limit its mathematical ability to connect disparate ideas in novel, perhaps slightly risky but highly creative ways. You put it in a straitjacket.
And even more critically, the text argues that by using human annotators to build a reward model, you are inherently, unavoidably, adopting the political or cultural biases of those specific humans.
You have to.
Right. If the armies of annotators lean a certain way politically, or if the corporate guidelines they are forced to follow dictate a specific worldview, the reward model will mathematically figure those viewpoints. It will pull the gravity toward that ideology. The AI isn't objective. It is perfectly aligned to the subjectivity of its human trainers.
This is such crucial context for the listener to internalize. Think about the last time you argued with a chatbot and the AI apologized to you. When it says, "I'm sorry, you are correct, let me fix that," it is not feeling guilt. It has no concept of remorse. It is not bowing to your superior intellect.
So what is it actually doing?
It is simply executing a highly optimized, human-injected apology template. The human annotators trained the reward model to heavily weight submissive, apologetic language whenever the user's prompt contains words indicating frustration or a contradiction. It is pantomiming empathy and subservience because we mathematically forced it to.
The author urges us to maintain our critical thinking here. Do not be charmed by this engineered politeness. Recognize it for what it is. A forced alteration of probability weights designed to make a commercial product user-friendly.
Which is a perfect pivot to what the author tackles next. Because understanding how AI actually works, understanding that it is math, not magic, and that its personality is just RLHF correction fluid, allows us to see through the massive amount of garbage being peddled by self-proclaimed AI experts online.
And I want to pause here for a second. The author goes on a very strong, very aggressive offensive here against the hype machine. And just as a quick note to you listening, we are neutrally reporting the author's opinions here. We aren't taking sides in the tech influencer wars.
Right, just analyzing the text.
Exactly. But the author's core argument is that these influencers use pseudoscience and heavy anthropomorphic buzzwords deliberately. They create an artificial information gap so they can harvest traffic, sell courses, and make money off of the general public's confusion and fear.
The critique is that these experts are intentionally polluting the information stream. By making AI seem like an unknowable, mystical force that might wake up and destroy us tomorrow, they position themselves as the necessary high priests who can interpret the oracle for you. For a fee, of course.
The source explicitly rejects a very popular concept that's been floating around the Chinese internet right now, and it's bled into Western discourse too. There's this idea that AI is just playing word solitaire, a game called Danziji Long.
Yeah, I've heard that.
It's the idea that the AI is just blindly guessing the next word, like a glorified autocomplete on your iPhone keyboard. The author says this is a dangerously narrow, biased view that completely misunderstands the global nature of the technology.
It totally diminishes what is actually happening. AI wasn't built on a simple word-guessing game. It was built on global codes, on the structure of the English alphabet, on massive structural logic from GitHub.
Not just guessing letters.
Right. When it generates text, it isn't blindly guessing the next word in isolation. It is executing precise path searches across billions of parameters based on those complex logical chains we talked about earlier. Calling it word solitaire ignores the multidimensional weight mapping of the transformer.
So if the word solitaire analogy is too simple, and the conscious machine analogy is science fiction, I have to ask, why do these experts make it so complicated? If the reality is just math and path searches, why wrap it in all this terminology?
Well, the author's logic is cynical but incredibly clear. If the general public truly understood that AI is just a giant math-based search engine running human data, the experts wouldn't be able to sell their expensive prompt engineering courses.
That makes sense?
They wouldn't be able to farm engagement on social media by predicting the robot apocalypse. If it's just an advanced calculator, it's not scary. By keeping the technology shrouded in mystery and fear, they maintain their own relevance. They are deliberately polluting the stream.
So how do we defend ourselves against this grift?
The author offers a primary defense mechanism: questioning. Relentless questioning. In an era of absolute information pollution, questioning the narrative is your only protective amulet. Whenever you hear an expert on a podcast or on Twitter talk about an AI's intentions or its feelings or its creativity, You have to question that premise instantly.
Just break it down.
Yes. If you strip away the mystical terminology, if you constantly remind yourself that you are dealing with a mathematical tool running deterministic code, you regain control over that tool. You stop being a passive consumer of hype and become an active, informed user.
I love that. Strip away the magic, regain the control. It's empowering. But once we clear away the fake hype and the apocalyptic predictions, what does the actual future of this technology look like? If it's not Skynet, what is it?
It's much more practical.
The source outlines a vision that is less about robots taking over the world and more about a fundamental restructuring of how digital files physically exist.
Yes. The author gives us a look at what we might call a unified native AI architecture. To understand this, look at how our digital lives are currently built. They are highly siloed. You have a video file in an MP4 format, an audio file as a WAV, a text document as a DOCX, a spreadsheet.
Sure.
They all exist in different formats using different codes, often locked within different competing software ecosystems. Apple, Google, Microsoft.
Right, they don't talk to each other natively. If I have a video on my phone, my Notes app doesn't know what's in that video.
Exactly. But the future the author envisions is a unified format across all these software giants. Soon, all data generated will natively include AI architecture from the very millisecond of its creation.
What does that actually mean, practically speaking? Native AI architecture. Break that down for me.
Let's take video as the prime example. Currently, a video file on your phone is essentially a massive, dumb collection of pixels changing color over time. If you want to find a specific moment in a video, say a scene where your dog catches a red frisbee at the park last summer, you have to either manually scrub through hours of footage or you have to use a heavy, separate AI program to watch the video and analyze the pixels after the fact.
It's just a lot of time, drains the battery, and requires immense computing power.
Exactly. But in the unified future, video will become text, meaning a video won't just be dumb pixels anymore. It will be a highly structured document with an embedded transformer weight table generated as the video is recorded.
Whoa, wait. Let me make sure I'm getting this. As the camera lens is physically recording the dog and the frisbee, the AI chip inside the phone is simultaneously creating a mathematical web of weights describing the semantic meaning of what is happening and saving it into the file itself.
Yes. The file itself contains the semantic understanding of its own contents. It knows it is a dog, it knows the frisbee is red, it knows it is a park. This allows an AI system to search the meaning of a video instantly, just like you would search a Word document for a specific word. It completely bypasses the need for heavy post-analysis.
That is mind-bending. The source says that hardware and software will achieve deep synergy. AI logic will be built directly into operating systems and chips, organizing and categorizing data the moment it is created. It means the end of organizing files into folders. The system just knows what everything is intrinsically.
And this brings up the ultimate sci-fi comparison from the text, though this time it's grounded in actual practical application. The author compares this future to Iron Man's Jarvis.
Right, but they're very careful to emphasize that this Jarvis isn't just a voice assistant that tells you the weather or sets a timer. We already have that, and it's not revolutionary.
No, this is much deeper.
This Jarvis is a system kernel. It operates at the base level of the computer. It has semantic, weighted access to hundreds of terabytes of your personal data. Your notes, your videos, your emails, your code, your location history, your heartbeat from your smartwatch.
Because all that data natively shares the same underlying AI architecture, your personal Jarvis can pull exact logical chains from your entire life's digital footprint instantly. If you ask it, what was that idea I had about optimizing the garden layout last spring, and how does it connect to the new irrigation system I just bought?
It wouldn't just look for the word garden.
No, it searches the semantic weights of your voice notes from last May, cross-references it with the hardware store receipt in your email from yesterday, looks at the sunlight data from your photos, and synthesizes a complete, perfectly logical answer.
It's an instant search engine for your entire life, connecting dots you forgot even existed. That is incredible. And the expert explains broader implications for this natively semantic data beyond just personal organization, things that could change entire industries, like autonomous driving.
Autonomous driving is actually the perfect test case for this future. Right now, self-driving cars are struggling because they use cameras and LiDAR to constantly scan the environment, and then an onboard computer has to interpret that massive, chaotic stream of pixel and point cloud data to figure out, is that a shadow of a tree or is that a pedestrian walking into the street?
Which requires heavy computation, and more importantly, it causes a physical lag.
Exactly, a lag that can be deadly at highway speeds. But if environmental data is native, say data broadcast from smart city infrastructure, or even semantic data formats broadcast from other cars on the road, it is already structured at the point of capture.
So no processing delay.
Right. The vehicle doesn't need to do that heavy interpretation. The data is inherently transparent. The car instantly knows the semantic reality of its environment because the data itself is pre-weighted with meaning. It's a massive paradigm shift from a computer interpreting the world to natively reading it.
It's a completely different way of interacting with digital reality. Okay, we have mapped the engine, we've debunked the myths, we've explored the click workers, and we've looked at the Jarvis future. The final, most important question remains: how do you, the listener, survive and thrive in a world that is being fundamentally reshaped by this technology?
The author leaves us with a very stark, very powerful philosophy at the end of the document. They state that if guns were the absolute weapon of traditional violence, AI is the absolute weapon of modern wisdom.
That is a heavy comparison.
It is, but it underscores the sheer stakes of what we are dealing with. In the past, physical force or access to exclusive, gated information dictated who held power. Today, AI provides universal, instant access to the sum total of human knowledge. Giving up this tool, ignoring it because it seems complicated, or refusing to use it because you believe the influencer fear-mongering, means leaving yourself functionally defenseless in the modern economy.
You are bringing an abacus to a supercomputer fight.
Exactly. And because of this democratization of knowledge, the nature of learning itself has permanently changed. Memorizing facts, knowing the answer, is practically worthless now. The machine can recall any fact instantly and perfectly.
So if memorization is dead, what is the new core competency for a human being?
Knowing how to ask the right questions and knowing how to rigorously filter the results. The author lays out a specific survival strategy for the modern mind. Read, refute, question, think, summarize. You have to be the critical human layer operating on top of the machine's mathematical output.
You have to guide it.
You have to verify the logic, challenge the assumptions, and synthesize the final meaning. The machine does the heavy lifting, but you have to steer it.
And this brings us to the absolute best part of this entire document, the ultimate twist. The author of this incredibly deep, highly technical, philosophically rich document, who goes by the internet handle, Sansi reveals at the very end of the text that they did not even graduate high school.
It is a brilliant, earth-shattering mic drop.
It really is. It reframes everything we just read. Sansi explains that they provided the core seeds of thought, the fundamental logic, the structure of the argument, the raw insights about hardware and software, but they used AI to expand those seeds.
They use the tool.
Right. They used the tool to flesh out the analogies, to structure the pacing, to correct the grammar, and to turn raw thought into a 10,000-word logical masterpiece.
The author is living proof of their own thesis. They used AI exactly as they prescribed. Not as a magic genie that conjures thoughts out of thin air, but as an advanced tool to organize, expand, and perfectly structure existing human thought.
The AI didn't create the ideas. The AI has no ideas. Sansi's messy human brain created the ideas. The AI empowered Sansi, a high school dropout, to articulate those complex concepts at a massive scale with the precision and structural integrity of a tenured computer scientist. It is the ultimate democratization of intellect.
It forces us to view AI not as a competitor, but as a digital mirror of humanity. When you sit down at your keyboard and ask an AI for help, you have to remember that you aren't talking to a machine. You are talking to thousands, millions of humans who left their wisdom, their code, and their experiences in the data.
The collective past.
Yes.
Yeah.
The machine's just the delivery mechanism for our collective history.
Our job now, as humans using this tool, is to ensure we are adding high-quality logic and thoughts back into that collective pool. We have to be the ones generating the original seeds.
Because if we stop generating original thought and rely entirely on the machine to do the thinking for us, we are just endlessly echoing the past. We have to use the tool to push the boundaries of what humans can conceptualize, not just recycle it.
Which leaves us with a final, slightly provocative thought to chew on. We talked at the very beginning about wiping the sci-fi myths from our brains, about looking past the murky, magical expectations and seeing the clean, mathematical reality underneath. The machine is just a compressed package of everything we have ever written, guided by mathematical weights. But what happens when AI starts training on the internet of tomorrow, an internet that is increasingly written by AI itself? As we all become like Sansi, using AI to expand our thoughts, how do we ensure the original, messy, purely human seeds of creativity don't get lost in the machine's perfect mathematical echo chamber? Something for you to think about until next time.